Hi students and friends, welcome to the channel Learn and Teach by Ayaz. In this video lesson, I'm going to explain you how you're going to solve CIE 5070 past papers. So today I have selected specimen paper 2, which will be followed for examination from 2023 and onward. Let's begin with the question. Here's the first question. Choose from the list of oxides to answer the questions. Here's the list. You have calcium oxide, carbon dioxide, copper 2 oxide, silicon 2, silicon 4 oxide, sodium oxide, sulfur dioxide, sulfur trioxide, zinc oxide. Each oxide can be used once, more than once, or not at all. Identify which oxide A has a giant covalent structure. For this, we'll see the structures of all these oxides. Calcium oxide is an ionic compound. So ionic compounds have giant ionic structure or giant ionic lattice. So I will write here giant ionic. Calcium oxide is giant ionic. Carbon dioxide, simple structure. So you write simple. Copper 2 oxide, it's an ionic compound. Again, giant ionic, Gi. Silicon 4 oxide, it must have giant covalent structure. So I will write giant covalent structure here. You see the other options also. Sodium oxide, again giant ionic. Sulfur dioxide, sulfur trioxide, both are simple. Zinc oxide, again giant ionic. So for part A, the answer will be silicon 4 oxide. Part B, reacts with acids and with alkalis. So this oxide must be reacting with both acids and alkali, and we have only one choice. If you look at all the choices, you have basic oxide, calcium oxide, carbon dioxide, acidic oxide, copper 2 oxide, basic, silicon 4 oxide, acidic, sodium oxide, basic, sulfur dioxide, sulfur trioxide, both are acidic. Zinc oxide is the only choice left. So it's the only oxide which reacts with both acid and alkalis. C is used in flue gas desulfurization. You can either have calcium oxide, copper 2 oxide, or sodium oxide. We know that copper 2 oxide is less reactive, it's not very much reactive. While sodium oxide is highly reactive, it reacts with everything. Calcium oxide is the oxide which is used in flue gas desulfurization for neutralization of acidic oxides. Calcium oxide. Part 4 contains a cation with a charge of +1. If you look at the cations, so where you will find cations. In this, you will find cation carrying, that is Ca, carries +2 charge. Copper, again cation, it will carry +2 charge. Any other cation? Yes, sodium oxide, it's Na plus. Zinc oxide, it is Zn +2. So the answer will be sodium oxide. Question number 2. Atoms and ions contain protons, neutrons, and electrons. Complete table 2.1. So this is the table 2.1, and there are some blanks. For instance, proton, you have to mention the mass of proton. Neutron, you have to write the charge for neutron. But for electron, you have to give the charge as well as mass of the electron. We know that proton has a mass of 1, and neutron does not carry any charge, so you write 0 here. What about the charge on electron? It's -1. For the mass of electron, the any fraction value between 1 by 1700 and 1 by 20 2000, sorry, 2000. So you can write 0 by 0.0005. Part B, table 2.1 shows some information about 6 particles. So part 1, deduce the nucleon number for particle A. For particle A, how you going to find the nucleon number for this? You will simply add up the protons and neutrons. That will be 37 plus 48. What you will get? You will get 85. Part 2, explain why particle B is a negative ion. Look at the number of protons and neutrons, number of protons and electrons for this particle B. If you look at this, 53 is the proton, 54 is the electron. So there's a difference between the number of electrons and protons. So you can write even has more electrons than protons. Has more electrons than protons. Part 3, identify two atoms that are isotopes of the same element. You have to find the two atoms in this that are isotopes of the same element. What are isotopes? Isotopes have same number of protons, different number of electrons. So if you look at these atoms, you'll find these having same proton number C, D, E. Now we'll look at the number of neutrons as well as number of electrons also, because if number of electrons different, then it must be the ion, not atom. So for D, if you look at the D, the number of electron is different. So you can't have D as the correct answer. So if you look at C and E, both have same number of proton but different number of neutrons. The number of electrons are also same. So answer will be C and E. So the answer will be this, and the explanation will be this: the same number of protons but different number of neutrons. Part 3, question number 3. Salts can be prepared by the reaction of acids and bases or alkalis, and also by precipitation reactions. A, state the ionic equation for the reaction between an acid and an alkali. Any acid and alkali, if you want to write the ionic equation, this ionic equation will remain same. That is the reaction between H positive ion coming from the acid and OH negative ion coming from the alkali. So, and the product will be H2O. Part B. Sodium sulfate is a soluble salt prepared by a titration method using an acid and an alkali. Identify the acid and the alkali used to prepare sodium sulfate. It's very easy. Sulfate, the sulfate ion is coming from acid, sulfuric acid. Sulfate from H2SO4. So you can write sulfuric acid. You can even write the formula of sulfuric acid, which is H2SO4. For alkali, sodium hydroxide is the answer. So NaOH or sodium hydroxide. C, aqueous sodium sulfate is used to prepare barium sulfate in a precipitation reaction. This is the ionic equation: Ba2 plus Aq, SO4 2 minus Aq gives PaSO4S. S means solid. In an experiment, 20 centimeter cube of 0.550 mole per dm cube of barium nitrate is added to an excess of sodium sulfate. Barium nitrate is limiting reagent, so we will use the data of this barium nitrate. State the color of the precipitate formed in the reaction. You have to write the color of the precipitate, that is BaSO4. It's always white, so we'll write white here. Now in 3 they are asking calculate the maximum mass of barium sulfate that could be made. First of all, you should know the number of moles of barium sulfate. If you look at this equation, so it's the reaction between sodium sulfate and barium nitrate. Sodium sulfate is Na2SO4 plus barium nitrate is BaNO3. One of the product is BaSO4. We are interested in BaSO4. We are not interested in the other product. If you look at the mole ratio, both BaNO3 and BaSO4, they have same ratio. BaNO3, BaSO4. So if you know the number of moles of BaNO3, then you can easily predict the moles of BaSO4 because it should be equal to BaNO3. 1 mole gives 1 mole of barium sulfate. So first, what we will do, we will calculate the number of moles of barium nitrate. I'm going to calculate the number of moles of barium nitrate from the data given. If you look at the data, 0.55 mole per dm cube means 1000 centimeter cube contains 0.550 moles. Therefore, 20 centimeter cube contains x mole. Do cross, you will get this x is equal to 0.550 multiplied by 20 divided by 1000. What will be the answer? 0.011 moles, which will be the moles of BaSO4. The MR of BaSO4 is given. So what you will do, you will multiply 0.011 by 233 to get the final answer. The final answer will be 2.563. This will be your final answer. A mass of 1.92 gram of dry barium sulfate is obtained. Calculate the percentage yield of barium sulfate. You will calculate the above data. It's very easy. .92 multiplied by 100, and the mass we have obtained is 2.563. So the answer should be between 74.9 or 75%. Question number 4. Calcium chloride CaCl2 is an ionic compound. Deduce the electronic configuration for each of the ions in calcium chloride. Now they are asking about the electronic configuration in ions. Calcium ion and chloride ion. Calcium ion will be Ca+2. If you recall the proton number of calcium, which is 20, so you have to subtract 2, you are left with 18. So what will be the electronic configuration? 2, 8, 8. What about chloride? Chlorine, its proton number is 17, which means 17 electrons. So it will get 1 electron to form Cl negative ion. So the same electronic configuration 2, 8, 8. B. When molten calcium chloride is electrolyzed with inert electrodes, calcium and chlorine are formed. Construct ionic half equations for the two electrode reactions. Reaction at the negative electrode. At negative electrode, what is moving? Positive ions are moving. There is a reduction taking place. Cathode, negative electrodes, cathode. So Ca+2 ion, it will take up 2 electrons to form Ca. What about positive electrode? That is anode. It's anode. That's cathode. Cl negative ion move towards anode and it will lose electrons to form Cl2 gas. Balance the equation, you will get this. The electrolysis of concentrated aqueous calcium chloride with inert electrodes is similar to that of concentrated aqueous sodium chloride. But in the products of the electrolysis of concentrated aqueous calcium chloride with inert electrodes, we know that calcium and sodium both are above hydrogen in the reactivity series. So you can't get metals at the cathode. You will get hydrogen gas H2, and as it is concentrated, so you'll get chlorine gas or Cl2. D. Calcium chloride has a high melting point. Explain why calcium chloride has a high melting point. Use ideas about structure and bonding. It's very easy when they are talking about the structure. It's giant lattice. Giant lattice. Straight away you'll write giant lattice. Now, bonding. Bonding is strong ionic. You can even write strong attraction between positive ion and negative ions. Question number 5, figure 5.1 shows the alcohols ethanol and butane 1-all. The figure, ethanol, butane 1-all. Describe the manufacture of ethanol from ethene. So you have to write the conditions. It's very easy. The reaction with steam will take place. Mention the name of the catalyst. That is phosphoric acid. Other condition, you have pressure and temperature if you want. But this is enough. These two is enough. Ethanol is used as a fuel. State one other use of ethanol. It's used as solvent or making vinegar. Or making vinegar. Construct a symbol equation to show the incomplete combustion of ethanol. It's very easy. Whenever you go for incomplete combustion of organic compounds, you will get two products. Steam or water will be the common product. The other product will be either carbon monoxide or carbon. So you have what will be the formula, molecular formula of ethanol is C2H6O plus O2. Combustion reaction involves the reaction between limited supply of oxygen and the organic compound CO or C plus H2O. You have to balance the equation. It's better if you write the balance equation. So if you are getting carbon monoxide, you write 2CO and water will be 3H2O. For carbon, it should be 2 carbon. Ethanol is oxidized to form ethanoic acid. State the name of a reagent that is used for this oxidation. It's very easy. You can write oxygen. Or you can even write acidified. Aqueous potassium manganate. It's 7. Part D. Draw the displayed formula of a different alcohol that is an isomer of butane 1-all. Now let's look at the structure of butane 1-all. I will draw the structure of butane 1-all here on the left hand side. This is the right hand side structure of butane 1-all. 1, 2, 3, 4. It's 1-all, so you'll have OH on the first carbon. Now you have two options. You can either move this group to any other position or OH. You can make the isomer of butane 1-all. It's very easy. I'm going to show both. So if we move this CH3, we get this C1, 2, 3. Now if I'll change the position of functional group, that is OH. What I will get? I will get this. C1. One, two, three, four. I'm changing the position of OH. You can place it here and place hydrogen. These two are possible isomers of butane 1-ol. Butane 1-ol is heated with concentrated sulfuric acid, which acts as a catalyst. Butane 1-ene and one other compound are formed. Draw the structural formula of but 1-ene. But 1-ene, 4 carbon. 1, 2, 3, 4. So you write double bond between first two carbon atoms. Now complete the valency of carbon. Each carbon 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This will be the deduce the other compound form in this reaction. Water is produced in this reaction. State the type. Number F, but2ene CH3CH. CH3 is a polymerized to give polybut2ene. State the type of polymerization that occurs. Additions, very easy. Number 2, draw the structure of polybut2ene showing at least one repeat unit. They are asking about showing one repeat unit for the polymer. We know that in polymers there won't be any double bonds, addition reaction. So this will be the polymer, one unit for the polymer. Thanks for watching. Please share my like and share my video. For more videos, subscribe to my channel and press the bell icon.